Welcome to the AI Research Roundup. I'm Alex. Today we're looking at this paper from the Hugging Face trending list, published on September 24th, 2025, just yesterday. The big hook is a single model that edits and generates both images and videos using one unified token sequence, and it reaches state-of-the-art, even surpassing some commercial systems. The paper is titled, EditVerse, Unifying Image and Video Editing and Generation with In-Context Learning. And as we will see later, the implications for model unification are quite significant. Beyond the core idea, the team curates 232,000 video editing samples and introduces EditVerse Bench, showing strong instruction following, temporal consistency, and emergent cross-modal editing skills. So Figure 1 shows a teaser that demonstrates broad editing coverage across videos and images. The upper panels present video editing tasks, like object removal, style transfer, camera changes, and multitask compositions that mix several edits, which signals robust instruction following. The lower strip highlights image editing examples such as pose change, object removal, style change, and camera change, so the unified model handles both modalities consistently. While Figure 3 shows how text and visual inputs are woven into one interleaved sequence, which means the model reads them in a single continuous order for in-context learning. The left panel illustrates a chat-style instruction with a video and the resulting edit. In the center, the token rows depict text tokens, vision tokens, and start and end of vision tokens converging into a concatenated stream. The right examples highlight flexible edits like object removal across varying layouts and lengths. Alright, Figure 2 explains the full pipeline that unifies editing and generation by feeding text and visual tokens into one transformer sequence. The model maps tokens through linear layers and a shared attention stack, which enables in-context learning because every token can attend to every other token. The right panel introduces rotary positional embedding, meaning a rotation-based scheme that encodes order across space, time, and sequence. Finally, the network predicts visual velocity, a direction vector that guides denoising toward the edited output. So, Table 1 summarizes the training data that powers the unified editor, separating image and video sources across editing and generation. The image side lists large instruction-based editing sets alongside classic text-to-image data, with any edit reaching about 1.2 M samples. The video side highlights two pillars: EditVerse editing data at about 232K, and EditVerse gen data at about 3.0 M, which bundles control to video, first frame to video, and in-painting pairs. So Table 2 reports how the unified editor stacks up on EditVerse Bench and what that means for practical editing. The headline is that it leads all open-source baselines across 7 metrics. VLM evaluation means a vision language model judges whether the edit follows the instruction. The system also maintains strong temporal consistency, which reflects stable appearance across frames. Against a commercial system, it trails in raw generation quality but scores higher on editing faithfulness. Wrapping up, 2 takeaways stand out. A single interleaved token sequence lets one transformer edit and generate both images and videos with strong instruction following, and a scalable video editing dataset closes the data gap, boosting temporal consistency. The broader implication is simpler creative pipelines and more general multimodal editors. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.